Magandang araw po sa ating lahat. Naimbangal daw kanya tayo amin. Ngayon po ang topic natin ay synchronous reactance, synchronous impedance at effective resistance ng mga alternators. At meron po tayong mga solved problems para dito mamaya. Nandito po ang relationship ng resistance, reactance at saka impedance. For sure, meron na tayong background nito from alternating current circuits. Sa calculation ng voltage regulation sa mga alternators, to arrive at a better value, kailangan natin ang values ng impedance nito. Kaya it is necessary to perform three simple tests. Nandito po yung mga tests na kinakailangan nila. We have the armature resistance test, open circuit test, at saka yung short circuit test. Unahin po natin dito sa may resistance test. Para po dito, ang field winding niya ay hindi po nakakonect doon sa may DC source. Kaya wala tayong excitation during this time. And at the same time, nakatigil po yung alternator natin. Meron po tayong DC source na i-connect doon sa dalawang terminals ng alternator. Meron din tayong rheostat dito para i-adjust yung voltage na papasok dito sa may alternator natin. And for this test, i-measure po yung voltage doon sa may terminals at ang kanyang current. Ang i-measure po dito ay yung tatlong pares ng mga terminals, line 1, line 3 dito. After that, i-measure din po nila yung line 1, line 2. Then, i-measure din nila yung line 2 and line 3 with the same process. After that, using this formula, makukuha po nila yung value ng resistance dun sa mga terminals. Hindi pa po ito yung value ng armature resistance per phase because this is measured in the terminals. Dahil kung titignan po natin dito sa figure, ang sinusukat po ay yung line 1 and line 3. Ibig sabihin, ang masusukat po dito ay yung series connected na resistance ng phase A at saka phase C. Therefore, in order to determine the value of the armature resistance per phase, yung resistance na na-measure doon sa may terminals will be divided by 2. At ang resistance na ito ay based doon sa may direct current. Since ang alternator po natin ay nag-operate sa alternating current, yung value na nakuha natin kanina dito sa may resistance test will be multiplied by a factor which ranges from 1.25 to 1.75 para ma-obtain yung value more nearly equal to the armature resistance kung yung alternator natin or armature winding po natin ay nag-operate na dun sa alternating current. Ibig sabihin po, mas mataas po ang value ng armature resistance sa may alternating current compared with the direct current. Pagdating sa open circuit test, the generator will be operated at synchronous speed at ang kanyang field winding ay nakakonect na sa DC source para sa kanyang excitation. Therefore, mag-generate na ng EMF ang armature windings nito. Ang function naman ng field rheostat dito ay upang mai-adjust ang value ng field current dahil unti-unting i-adjust ang value ng field current at i-measure kung ano ang values sa mga terminals ng generator natin. Gaya din sa resistance test, kukunin ang average value na masusukat sa mga terminals nito sa may line 1, line 2, line 2, line 3, and line 3, line 1. At ito ay ipa-plot dito sa ating graph. Ito po yung graph para sa may open circuit test. Terminal voltage with respect to the field current. Sa short circuit test naman, this test is performed with great care dahil ang pinag-uusapan po natin dyan ay short circuit. Merong mga ammeters na nakakonect sa mga terminals ng alternator at konektado din sila in Y kung i-analyze natin maigi itong figure natin. Again, sa short circuit test, the alternator is operated at synchronous speed. Then gamit ang field rheostat nito, i-adjust pa rin po natin yung kanyang field current. Mag-generate din po yan ng voltage at dahil meron tayong short circuit, makaka-measure po tayo dito ng current. Gamit ang field rheostat, progressively tinataas ang value ng field current at kukunin din ang average value ng tatlong ammeters with respect to the value of the field current. Ito naman po yung graph natin para sa may short circuit curve. Para po dito, sa may certain value ng field current na magbibigay ng rated alternator terminal voltage per phase, doon nila kukunin ang value ng short circuit current. Halimbawa sa graph na ito, ang alternator ay may rated voltage na 2,300 volts. Kung kukunin ang per phase value na ito, 2,300 volts divided by square root of 3 equals 1,327 0.906 volts. And based on the value of the field current po nito, Nandito naman po yung value ng short circuit current. Nandito po ang mga formulas na kakailangan natin para sa resistance, DC value and AC value, synchronous impedance, at gamit ang right triangle for impedance, by Pythagorean theorem, ito naman po ang equation natin para dyan. With the open and short circuit test, ang makukuhang value kasi ay ang synchronous impedance. And by resistance test, of course, armature resistance naman ang makukuha doon. Kaya using this equation, pwedeng makuha ang value ng synchronous reactance dahil makukuha natin yung effective resistance at yung synchronous impedance by using the resistance test, open circuit test, at yung short circuit test. Proceed po tayo dito sa mga sample problems natin. Number 1 problem, to get the armature resistance of a 100 megawatt, 13.8 kilovolts and 90% power factor generator, two terminals are connected to a DC source. The measured current and voltage are 87.6 amperes and 6 volts respectively. What is the DC resistance per phase? So ang hinahanap po natin dito ay yung kanyang DC resistance per phase. It is assumed that this generator is connected in Y. At ang formula po natin para dun sa DC resistance per phase, ito po yan. Pero kinakailangan po muna natin kunin yung value ng resistance doon sa mga terminals nila. Ito po yung formula na gagamitin natin dyan. The resistance between the terminal equals the measured voltage divided by the measured current. Substitute po natin yung value, 6 volts divided by 87.6 amperes. This is equal to 0.0685 ohm. Ngayon, pwede na po natin makuha yung DC resistance per phase. Divide lang po natin ito ng 2. At ang sagot po natin dito ay 0.03425 ohm. Na kung titignan po natin dito sa mga choices, we have letter B. Next problem, a generator is rated 100 megawatts, 13.8 kilovolts and 90% power factor. The effective resistance is 1.5 times the ohmic resistance. The ohmic resistance is obtained by connecting two terminals to a DC source. The current and voltage are 87.6 amperes and 6 volts respectively. What is the effective resistance per phase? Ang hinahanap na po natin dito ay yung effective resistance per phase. Meron tayong given ng factor that is 1.5 at kinakailangan muna nating hanapin yung resistance niya per phase sa may direct current. Ito po yung gagamitin natin dyan. Pero bago natin makuha yung DC resistance per phase, kinakailangan muna nating masolve yung value ng resistance between the terminals of the alternator. Andito po yung formula na gagamitin natin. Ang voltage po niya ay 6 volts at yung current po niya ay 87.6 amperes. Substitute po natin yung values. 6 volts divided by 87.6 amperes will give us 0.0685 ohm. At i-substitute na po natin dito, meron tayong 0.0685 ohm divided by 2 equals 0.03425 ohm. Na pwede na po nating i-substitute dito. 1.5 times 0.03425 ohm. Ang value po nito ay 0.051375 ohm. Na kung titignan po natin dito sa mga choices, ang answer po natin ay letter A. Punta naman natin ang problem na ito. A 500 kilovolt amperes 2300 volt 3-phase alternator is tested and has a short circuit current of 204 amperes at an open circuit voltage of 2300 volts. The average DC resistance of the three armature windings phases between pairs of terminals RT is 0.8 ohm. For letter A, calculate the values of the synchronous impedance and synchronous reactance. Assume that the effective AC resistance is 1.5 times the DC resistance. For letter B, calculate the percent regulation for full load power factor of 0.8 lagging. Unahin po natin dito sa may letter A, we will solve for the synchronous impedance and synchronous reactance. Para po sa kanyang synchronous impedance, ito po yung gagamitin natin. Open circuit voltage, divide this by short circuit current. And since meron po tayong 3-phase alternator and this is assumed to be Y-connected, yung open circuit voltage po na kukunin natin ay dapat yung per phase value. Para makuha po natin yan, open circuit voltage between the terminals divided by square root of 3. Ang value po natin doon ay 2,300 volts. Divided by square root of 3 will give us 1,327.906 volts. Na pwede na po natin i-substitute dito sa ating formula. Ang value ng short circuit current po natin ay 204 amperes. Substituting the values, 1,327.906 volts divided by 204 amperes will give us 6.509 ohms. So ito na po yung sagot natin para dun sa synchronous impedance. Kunin naman po natin yung kanyang synchronous reactance. Based po tayo dito sa may impedance triangle. Meron na tayong value ng synchronous impedance. Ang hahanapin natin ay synchronous reactance. Ngunit dapat kunin muna natin yung kanyang effective resistance per phase. Based from this impedance triangle, meron po tayong Z squared equals RAC squared plus XS squared. Simpleng Pythagorean theorem lang po ito. To solve the value of the synchronous reactance, transpose muna natin itong RAC squared dun sa kabila. Kaya magkakaroon tayo ng ZS squared minus RAC squared equals XS squared, na pwede nating i-rewrite into synchronous reactance squared equals synchronous impedance squared minus effective resistance squared. Square root po natin yan both sides. Kaya ito ay magiging synchronous reactance equals the square root of the synchronous impedance minus the square of the effective resistance. Meron na tayong given ng synchronous impedance pero wala pa po tayong given ng effective resistance per phase. Ito po yung formula na gagamitin natin dyan. Ngunit kinakailangan muna nating hanapin yung value ng DC resistance. Ito naman po yung formula natin para dun sa may DC resistance. Yung value ng ating RT, yung resistance between the terminals is 0.8. Substitute po natin yan. DC resistance equals 0.8 ohm divided by 2 which is 0.4 ohm. Na pwede na po natin i-substitute dito. Yung value po ng factor natin ay 1.5 times 0.4 ohm. This is 0.6 ohm. At gamit po yung dalawang values na ito, substitute po natin dito sa formula ng synchronous reactance. We have the square root of 6.509 minus the square of 0.6 equals 6.481 ohms. So, ito na po yung sagot natin para sa letter A. Punta naman po natin itong letter B. Calculate the percent regulation for a full load power factor of 0.8 lagging. Ito po ang formula na gagamitin natin dito. Percentage voltage regulation equals the generated voltage per phase minus the load voltage per phase divided by the load voltage per phase times 100%. Although syempre, ang representations po ng mga voltages na ito, yung generated voltage represents the no load voltage at yung full load voltage naman po ay nire-represent ng load voltage natin, VP. Based po tayo dito sa phasor diagram na ito. Pinag-aralan na po natin ito dun sa mga previous lessons natin. Ngunit isolve po natin ito sa mas simpleng paraan. Andito po yung voltage drop sa may resistance at yung combined voltage drop sa may reactance at yung armature reaction. Kung isi-simplify po natin ito, dahil meron po tayong synchronous impedance, ito na po yung total voltage drop doon sa may voltage drop sa resistance at doon sa combined voltage drop sa may armature reaction at armature reactance. Kaya kung isi-simplify po natin itong phasor diagram natin, ito na lang po siya. Meaning to say, the generated voltage equals the vector sum of the load voltage per phase plus the voltage drop in the impedance per phase of the alternator. Na yung voltage drop dun sa may impedance equals the phase current times the synchronous impedance. Simpleng ohms law lang po ito. To determine the current IP, meron tayong formula, the apparent power divided by the square root of 3 divided by the line voltage. Ang value po ng apparent power natin is 500 kilovolt amperes or this is 500,000 volt amperes. Yung line voltage po natin is 2,300 volts. Substitute po natin 500,000 volt amperes divided by square root of 3 and 2,300 volts. Meron tayong 125.511 amperes. Ito pa lang po yung magnitude ng ating current. Since vector sum po ang pinag-uusapan po natin, ibig sabihin kinakailangan din po natin kunin yung value ng angle ng ating current. To do that, mula po dun sa formula natin for the power factor which is cosine theta, deriving this formula, theta equals the inverse cosine of the power factor. Yung power factor po natin is 0.8, kaya ang angle po natin dyan ay 36.87 degrees. And since meron po tayong lagging power factor, ibig sabihin po ito ay magiging negative na po. Kaya ang IP natin, we have 125.511 angle negative 36.87 degrees amperes. Ngayon kunin naman po natin yung synchronous impedance natin. Meron na po tayong value kanina which is 6.509 ohms, pero kinakailangan din po natin kunin yung kanyang angle theta. Typical na ginagamit po nating formula dito which involves the synchronous reactance and the AC resistance per phase is by using tangent. Dahil sa relationship po nila, tangent theta equals the opposite divided by the adjacent. Ang opposite po dun sa theta natin, that is the synchronous reactance, at ang kanyang adjacent side ay yung effective resistance. Na pwede na po nating i-substitute dito. We have the inverse tangent of 6.481 ohm divided by 0.6 ohm. Angle ng impedance po natin ay 84.711 degrees. Kaya po pwede na po nating i-rewrite yung ating impedance as 6.509 angle 84.711 degrees ohms. Na pwede na po nating i-substitute dito sa ating formula dahil meron na po tayong value ng current natin. Substitute na po natin ang dalawang ito dito sa formula natin for the voltage drop of the impedance. 125.511 angle negative 36.87 degrees amperes times 6.509 angle 84.711 degrees ohms. This will give us 816.951 angle 47.841 degrees volts. Kaya meron na tayong value ng voltage drop, easy. Para sa load voltage po natin, simpleng formula na lang po ito, line voltage divided by square root of 3. 2,300 volts divide this by square root of 3 equals 1,327.906 volts. And since it is resting on the x-axis, ang angle po ng load voltage natin dito ay 0. So using this equation, substitute na po natin yung ating mga values. The generated voltage equals 1,327.906 volts plus 816.951 angle 47.841 degrees volts will give us 1,971.548 angle 17.889 degrees volts. Kung titignan po natin dito sa phasor diagram natin, eto na po yung mga yan. Anyway, ang kinakailangan lang po natin dun sa ating voltage regulation ay generated voltage at ang kanyang load voltage. Yung magnitude lang po ay ini-include natin dyan. Ibig sabihin, hindi na po natin i-include yung angle 17.889 degrees dito kay generated EMF. Substituting the values, 1,971.548 volts minus 1,327.906 volts, divide this by 1,327.906 volts equals 48.47%. Dito naman po tayo sa last problem natin. A 50 kilovolt amperes 550 volt single phase alternator draws a field current of 10 amperes at rated load. With the same field current, the open circuit EMF and the short circuit current are 300 volts and 150 amperes. The ohmic resistance of the armature between terminals is 0.18 ohm. The ratio of effective to ohmic resistance may be taken as 1.5. Determine the regulation at 0.8 power factor lagging. Again po, ito po yung typical na formula na ginagamit po natin para dun sa may percentage voltage regulation. At dito sa problem po natin, tinukoy po niya single phase alternator po ito. So ibig sabihin, yung full load voltage po niya is 550 volts at hindi na natin kukunin yung per phase voltage since meron nga tayong single phase alternator. Para sa no load voltage naman po nito, ang kukunin nating value ay yung kanyang generated voltage. Habang ito ay nag-ooperate ng full load voltage at rated load 50 kilovolt amperes. And for the generated voltage, we have the vector sum of the full load voltage plus the voltage drop dun sa kanyang impedance. At ang voltage drop dun sa may impedance could be written as the full load current times the synchronous impedance. Again, meron na po tayong value ng full load voltage, that is 550 volts. Kinakailangan po natin kunin yung kanyang full load current, that is apparent power divided by the full load voltage or the rated voltage. 50 kilovolt amperes or 50,000 volt amperes divided by 550 volts equals 90.909 amperes. At kunin din po natin yung kanyang angle, again from the formula of the power factor na dinerive na po natin. theta equals 36.87 degrees. Do sa problem, sinabi po niya lagging po tayo, kaya meron tayong 90.909 angle negative 36.87 degrees amperes. Ngayon naman po, ang kunin natin ay yung kanyang synchronous impedance. Ito po yung mga given natin for open circuit EMF and short circuit current. 300 volts at saka 150 amperes. Substitute lang po natin dito. 300 volts divide this by 150 amperes will give us 2 ohms. Ngayon, kunin naman po natin yung angle ng synchronous impedance. Base tayo dito sa impedance triangle. Take note po yung AC resistance po ang kukunin natin. Ito po yung formula na gagamitin natin dyan. From our problem, ang value po ng factor na multiply natin is 1.5. And yung RT or yung resistance dun sa may armature between terminals, that is 0.18 ohm. Take note po, meron po tayong single phase dito kaya hindi na po natin i-divide yung 0.18 ohm ng 2. So effective resistance equals 1.5 times 0.18 ohm, meron tayong 0.27 ohm. Kahit hindi na po natin kukunin yung value ng synchronous reactance dito, pwede na po natin makuha yung angle ng synchronous impedance. Because based from the trigonometric function, pwede po natin makuha yung relationship ng adjacent side sa yung hypotenuse nito. Based from trigonometric function, meron po tayong cosine theta. Yung adjacent side po nito, we have the RAC at yung kanyang hypotenuse naman ay yung kanyang synchronous impedance. Deriving our formula, theta equals the inverse cosine of RAC divided by ZS. Substitute lang po natin yung mga values na nandito. We have the inverse cosine of 0.27 ohm divided by 2 ohms. Ang angle po natin dito ay 82.241 degrees. Na pwede na po nating isama dito sa my synchronous impedance kaya meron tayong synchronous impedance equals 2 angle 82.241 degrees ohms. At gamit po yung mga values na na-solve natin, pwede na po nating i-substitute dito sa may equation natin para makuha natin yung value ng generated voltage. Therefore, the generated voltage equals 550 volts plus 90.909 angle negative 36.87 degrees amperes times 2 angle 82.241 degrees ohms. This is equal to 689.971 angle 10.809 degrees volts. At meron na po tayong value ng generated voltage at yung kanyang full load voltage na pwede na po nating i-substitute dito sa ating formula para sa percentage voltage regulation. Again, yung no load voltage po natin dito equals the generated voltage. I-substitute lang po natin 689.971 volts minus 550 volts divide this by 550 volts times 100% will give us 25.45%. Na kung i-base natin dito sa may choices, ang sagot po natin dyan ay letter C. So yan lang po muna sa araw na ito. Sana po meron po tayong natutunan. Maraming salamat po. Magandang araw po sa ating lahat. Naimbag nga aldaw kanya tayo amin.